there. We're going to read it. What's the next thing we need to do after we read a word problem or a story problem? I should see everyone's hand because we've done a lot of work with story problems. If you don't know, you've been figuring it out. Sitting there doing nothing and not figuring it out. Yeah? Yeah, we didn't know what I'm counting, my unit. We're going to be writing an answer sentence. Let's look at the problem. Miss Miller is making banana pudding for a picnic on Saturday. Lovely. She bought 4 bunches of bananas. Each bunch had 5 bananas. How many bananas did Miss Miller buy? Read that one more time in your head. What am I counting? What am I counting? Rylan, what am I counting? Counting bananas. Who can take my question part of this problem and turn it into an answer sentence? New answer sentence. I'm not looking for the answer. I'm leaving a blank for my answer. Go for it, Kaden. That works. Miss Miller bought, and then there's my unit, blank bananas. That's what I'm counting. Blank bananas. Right, so we're writing. All right, got bananas. Cool. What's the next thing I need to do? Write the problem. I know what I'm counting. What is the next thing I need to do? Ariana? Can you turn it and face me and say it so I can hear you? Make a model. Let's go ahead and crank out our bar model. Bryson, what am I counting again? Bananas. Do I know the total amount of bananas? No, not yet. Let's put a question mark. I don't know the total or the whole amount of bananas. But I know something. Jacqueline, what's something that I do know? Yep. What else do I know about those bananas? Yep, look at that word problem. That's where all my information is. Sure. Huxley, what else do I know about those bananas? There's 5 bananas in each bunch. How many bunches did I buy? Heidi? What is a bunch? What's that word mean? Madison? Yeah, it's like a group when they're all stuck together. So I bought 4 groups, 4 little mini banana packs. So down here, I'm going to make 4 spots. Why did I make 4 spots? Right. Why did I make 4 spots? Carl? Yeah, I got 4 bunches. What else do I know? Evelyn? because I don't even have any numbers. Colby, what do I know? I don't know that. I don't have any numbers. I have a question mark and I have 4 boxes. That's all I got. See again? Each bunch has 5 bananas. So how many bananas is in this bunch? 5. Put it in there. What about this bunch? What about this bunch? What about this bunch? Hey, that looks a little different than part whole, doesn't it? It is now part whole. Do you see it?
Yeah.
Alright, I have a model. Now I can make an equation. Let's start with an addition equation. What addition equation matches that model? Just parts and wholes, parts and wholes. We know how to do parts and wholes. Huxley, wake up. Yep. Nope, that's not what I asked for. I asked for an addition equation. Bryce, I'm not convinced you're paying attention. Jalen? Keep going, it's an equation. Equals spot saver. Now, that's repeated addition. We now know a shortcut for repeated addition. What's another equation I could write that matches that model? You know? No. You gotta listen to the question. If you've got right answers, they just don't match my question. Evelyn? 4 groups of 5. Keep going, it's an equation. Equals alright. We've got a model. We've got 2 equations. Both will work. Pick your poison. Now you can solve it. What is 5 plus 5 plus 5 plus 5 or 4 groups of 5? Heidi? 20. Does that make sense? Lower box 20 bananas. Does that make sense? Why is the answer not 9? Because I know a lot of 3rd graders would say, 4 and 5 make 9. Why is it not 9? We know it's not 9. We just did all the work. But how do we know it's not 9? Right?
It's not like 4 bananas and 5 bananas. That's like how many bananas.
Brilliant. Say it again a little louder because you got to say and go it.
It's not like 4 and 5 bananas. It's like 4 and 5 bananas.
Yeah, we're not just saying 4 bananas and 5 bananas. That would be 9 because I'm counting bananas. But that 4 is groups of bananas. That's very different. It's a whole different unit. So far, so good? Alright, turn the page. I want to go over some vocabulary. So go ahead and title it Parts of a Multiplication Equation, and then write that equation underneath. I want to just talk about some vocabulary that you're going to see. Who can read this equation to me in English? Translate that into English. Go for it, Zach. Three groups of 2 is the same value as what? Okay. So far, so good. Which one of these is the whole for the total? Which one of those symbols is the whole for the total, Carl? 6. Put whole slash total, because I use those words interchangeably, like they're synonyms. What are the parts? What are the parts? 3 and 2 are my parts. That's not new. We saw that just a second ago in our bar model. Right? So far, so good. So now I'm going to tell you what some of these words are in the math world, what the correct name for some of these are. We remember when we're adding, the name for the total in an addition problem is called a sum. Right? You've heard that before? It's not called a sum in multiplication round that one comes in. Because I'm not adding. I'm now skip counting. It's got a different name. So our whole or our total is also called the product. That's what mathematicians call the total of a multiplication equation. You're going to see that. The product. You're what? Our parts have the same name. Those parts are also called factors. They're called factors. So you might see things, let's say maybe, what is the missing factor? Or what is the missing part? Or it might say, what is the product? What's the total? You're going to see those words, so I just want you to make sure you know what it means. So far, so good. The reason why they have the same name, we kind of touched on this a little bit. 3 groups of 2. I'm writing, you're writing. Is worth the same amount as 2 groups of 3. Do those look the same? No. If I have 3 groups of 2, I've got something that looks like this. 2 for you, 2 for you, 2 for you. If I have 2 groups of 3, that looks like this. Those models and pictures, they look different. They're not the same. But my total is the same. They have the same ending value. The reason why is because these are both the same name. They're both factors. So I can flip-flop them. We can do this in addition too. You've got that special math property. What was that called when we did it in addition? Where we could flip-flop and still get the same value. Zach, you remember? Beautiful. Commutative property. Oops. That's what that's called. Property. Chris, you get that written down?